Okay, so this test portion 12H for class 10 math, science, these questions. Okay, so let us start with the first one, question number 1. All are on page 232. Okay, let me read the question for us. Page 232, we go there to your textbook. A piece of wire of resistance R is cut into 5 equal parts. Okay, these parts are then connected in parallel. So let us do that. See here, there's a wire 1, 2. Okay, let us say this is the one, and it is divided into 5 equal parts. 1, 2, 3, 4, and so let us say 5. So before it was cut out, it has the resistance of R. Now they're cut into 5 equal parts, means this 5 R is divided into 5 parts, means we can understand R by 5, right? R by 5, and each of these small wire after cutting will have this value of R by 5. And after cutting, it was changed into parallel connection. 1, 2, 3, 4, one more, 5. Parallel means one above the other they are put, so in this manner connected to battery. So between those same 2 points A and B, first one R by 5, second one, third one, and fourth one, and the fifth one, right? So these are connected in parallel, means one above the other between the same 2 points. So we have to find the ratio R by R dash. Okay, so let's write here. Since according to the question, the wire, okay, the resistance, the wire of resistance R is cut into 5 equal parts. Each part of the 5 part, right, each part will be value R by 5, right? So let us do that now. Since they are connected in parallel, so you write use, let here, according to the question, R dash, look into your question, R dash is the equivalent resistance. So R dash is the equivalent resistance of the 5 resistors, that means the 5 small resistors in parallel. Therefore the formula will be this one here. So let us write here 1 by total is here R dash will be reciprocal of the first one, 1 by value of the first one is R by 5 plus 1 by R by 5 plus 1 by R by 5 plus 1 by R by 5, 1, 2, 3, 4, and one more, plus 1 by R by 5. So that gives you here 1 by R dash is equal to 1, and then into means down will go up, 5 will go up, and R will come down. So 1 5s are 5 by R. So same thing, so we just do 5 by R plus 5 by R plus 5 by R, 1, 2, 3, 4, and one more, 5 by R, right? So next here 1 by R1, that implies is equal to here, see here, if you add this 1 by X plus 1 by X plus 1 by X, we can write it as 3 times, so 3 into 1 by X. Similarly 5 by R added 5 times, we can simply write it as 5 multiplied to one of them. Same thing, right? We can do like that also. So next we can continue. So come up here if you want. That implies here 1 by r dash is equal to 5 5s are 25 by r. See here, 5 5. So if you cross multiply down and up, 25 r dash is equal to r1s are r. So that implies r, sorry, not r1, r dash is equal to r, and this 25 will come down. So let us put this one as equation number 1. We can proceed. Required ratio. So if you look there into your question, the question is saying, look there once more, then the ratio r by r dash, how much is that? So therefore r by r dash will be simple as this, right? R is just, we can write the same thing. R dash value you can take from here, r by 25. Make sure this line is longer than this one, because this is the main division line. Okay, so here, since we can write here using equation number 1, then this value, if you change this division line into multiplication sign, down denominator 25 will go up and numerator will come down, right? So if you cancel this, you're going to get 1 is left, so 25 is to 1, or we can also simply write it as 25. So this is a multiple choice question, so the answer right choice there is D, which is matching with this answer, 25. Okay, now we'll go to the next one. The next one is question number 3. Let's do slowly. Number 3. Let me read the question. Electric bulb is rated 220 volt, 100 watt. Let us do that part. So there are 2 cases here in this question. So case 1 is electric bulb is rated 220 volt, means there is the potential difference, which is 220 volt, which is simply called as potential difference or voltage also. So we can just put here 1 for case 1. Then the question in first sentence, and 100 watt. So 100 watt is the unit of power, so we know that. So P1 is equal to 100 watt is the power of the bulb. Now you see here P, V, and let us relate to this number 10 formula, R. Resistance of the bulb will be the same even in the second case. So this is the resistance, because the same bulb is going to be used even in the second case. So R we need to find out. So next here, since formula number 10 is matching, P1 is equal to V square, so V1 square by R, because we're using V1 and P1. So here, using this formula number 10, we want to find R, so shift it and it will come R into P1 is equal to V1 square. Shifting this, it will go to the numerator. So R will be V1 square by P1 will come down. Let's do slowly. So they'll give you here V1 value is 220, so 220 volt into 220 volt, because this is V1 square, so 2 times we have to write. And P1 is here 100, so just write here 100 watt, right? And we cancel this 0 and 0. Okay, cancel this 0 and 0. Then this 0, second one, then you're going to get 22 into 22 left. So if we multiply, we get here 4, 2 2s are 4, here also 4 4, 484. So this will be 484, and SI unit of resistance is ohms, so we write your ohms, because volt, watt, everything is an SI, so resistance will come out in ohms. So let us put this one as equation number 1. Let's go to case 2. case 2 is, go there, second sentence. When it is operated on 110 watt, the power consumed will be, okay, you can just write it in the same form. When it is operated on let us say P2 equal to 110, V2 voltage 110 volt. The question is saying the power consumed. So the power, let us use the power here, P2 consumed will be, so this is a question mark. So what is P2 they're asking? So we write here, since again using the same formula, this number 10, this time P2 is equal to V2 square by R will be same because the same bulb is being used, so the same bulb means the resistance will be same. So let us write here V2 we already have here 110 volt into 110 volt 2 times because V2 square, and R we already have calculated here 484 ohms. I'm going to write here since using equation number 1 to get this value 484 ohms. You can see that the 11 is going very easily here. So 11 4s are 44, 45, 46, 47, 48, 4 in hand. That will go in front of the next 4, and 44, 11 4s are 44. So likewise 11 1s are 11 and 0. Then here 11 4s are 44, 11 1s are 11, 0. 4 is left, so let us do this carefully. So here 4, 2 2s are 4 and 2 5s are 10. 2 1s are 2 and 2 5s are 10. So we're left with 5 5s are 25. And SI unit of power is watt, so we write here. Therefore, power consumed in the second case, which the question is asking, is 25 watt. So multiple choice question. So the look into your text, then D, choice D is matching this 25, so 25 watt is our answer, right? Okay, one more question before we complete. So 4. Let me read the question for us. Question number 4. Same page. 2 conducting wires, okay? 2 conducting wires of the same material and equal length and equal diameters are first connected in series and then in parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel would be, so let's just start it since, okay, since question is clearly saying the 2 wires, okay, the 2 wires of the same material and of equal lengths, and also everything is equal diameter. So that means that basically the wires are identical materials, everything, okay, materials. Okay, so both will have, because of this we understand ourselves this one, both of these will have the same resistance value. Okay, we don't know how much, but it will be R, let us say. So first they are connected in series, so let RS be the total resistance value of the 2 resistors of the two resistors which are of equal value, R and R, as you can see here, in series first. Then if it is series, the formula is total RS is equal to R1 plus R2. So R1, the first one is R, second one also R, so this will be 2R. Okay, this one is 1. Again, they are disconnected and connected in parallel also. So let's just write here, let RP be the total. Same way you can go resistance value of the two resistors of the two resistors, okay, of the two resistors R and R, but this time in parallel. Okay, so this is so, then you can write here, therefore their total will be formula R by 1 by RP. Parallel formula we have to use. Reciprocal of total will be reciprocal of first one, 1 by R, plus second one, 1 by R, 1 by R. So that will be equal to 1 by RP. So we can go like this if you want. Is equal to 2 into 1 by R, because 1 by R plus 1 by R, just like 1 by X plus 1 by X is 2 into 1 by X, so 2 into 1 by R. Then we can cross multiply. 2 into RP is 2 RP up and down, and then up and down R1s are R. So RP, just keep it on one side, this one R, and this 2 will come down. So this one is 2. Go back to question, and the question is asking the ratio of heat produced in series and in parallel. So let's just write down required ratio. Question is saying heat produced in series, heat produced in when they are in series, and divided by heat produced when they are in parallel. This is what the question is asking us. So let us see which heat formula will match in our case. There's here 12, 13, 14, which one? Okay, let us use here. Okay, why 1 minute after this? Just wait, okay, just cut it off once, sorry. It's okay, but this is going to be shorter for you, so go back to question. And there is one important information. Since they're they are connected in the same, okay, since they are connected across the same potential difference, you can see that in the question. There's, since they means the two resistance are, look into your question, connected across the same potential difference. Look there, it's there, right? Across the same potential difference. Therefore, let V is equal to potential difference across both cases. Both means when they are in series as well as when they are in parallel. Let us add a word here. T is equal to time for current flow. Time allowed for current flow, total time. Same for both, right? Clearly the question says potential difference is same for both, so we put later, and time should be same. So let us write down the final answer. Three steps, or two more are there, I think. So let's write here, required ratio. I'll look into your question now. Will be equal to heat produced when in series, right? Heat produced when in series divided by heat produced when in parallel. So let us choose the appropriate heat formula here. There are three of them. Here see VIT, v squared t, and then I square, one more is there, 15. Here also is the I square h equal to E equal to I square RT is also there. So let us see. Here V is there, T is there, R is there. So VTR, see here, VTR in both cases are there. Here equation number 1, let us not forget RS is equal to 2R. So R is involved. So RVT. That is the only formula here. Heat H equal to E. Heat equal to energy, same thing, V squared T by R. So first case, V squared T by series means the value is RS. So we're using this formula 14. And the next one, heat produced in parallel, is same formula, V squared T, same potential difference, so V times same, and only thing difference is value of resistance in parallel is RP. And we write here since using equations 1 and 2. Okay, now once we're through with that, then we can write here it will be equal to V squared T by RS, and change this long line means divided by the multiplication, then down denominator will go up, and numerator here V squared T will come down. So this V squared T cancel means we have here RP left. So RP is, you can write down once if you want, RP by RS is our final value. So long line RP, as we can see here, is R by 2. Oh, not yet, not using this one, just wait 1 minute, just cancel it. This is okay, don't write. Then here RS here is twice R, and we can write here since using equations 1 and 2. So 1 value is coming here in place of RS, 2R, in place of RP from equation 2, R by 2. So we can solve this. That will be equal to R by 2, then change this long line divided into multiplication sign, then we know 2R means R by 1, so 1 denominator will go up, 2R will come down, so RR cancel means 1 is left on the numerator is 2, down there 2 2s are 4 in ratio 4. So the right answer that match this one is in C. So the C is the answer, 1 is to 4. I hope that's clear, right? So we can now go and give the test with this 12H. Okay.